Hello there and welcome back to the next video. I have been referring to this picture for a while now, so we're actually going to take a look at the life cycle of a star. I'm thinking that I should have put this before the terms, and then the terms would make a little more sense. But let's take a look at this diagram on page 24 of your student text, and this is not in the textbook. This is just a picture that I pulled off the internet to illustrate to you how a star is born and how a star dies. So we're looking at this model of really two different paths. Remember that we always follow our arrows to understand what's happening. So we're going to look at life cycles of an average star, which is this yellow one, and then a massive star, which is the blue one. So if you think of an average star as our sun, there are stars that are much larger than our sun, so those would be massive stars. But to start with, I want to just tell you sort of a fact about all stars. So throughout a star's life, stars fuse or bind, join together hydrogen, which is the simplest element that we know of, to form helium. So stars are burning, they're very hot. That's why they give off light and energy. Stars fuse hydrogen to form helium, and that's going to be important here in just a minute. So the first thing that we're starting with is this concept of a stellar nebula. And I want to be sure that I have given you the morpheme. So I'm going to flip back quickly to my morphemes page. And let's make sure that we have stellar on there. If you don't already have this term stellar, I want you to write that on your list of morphemes. Stellar means star. So if your teacher tells you that you are a stellar student, that means you are a star student. That's a very good thing. Stellar is star. So we are looking at, let me find my page again, I'm sorry. We are looking at a stellar nebula to begin with. So we're in this area right there, and that's not going to work. Let me try this. Let me get a white pencil for just a minute. Yeah, we're starting on this side of the diagram with the stellar nebula. When you see the word nebula, think of cloud. So this is a star cloud. And you can see that this stellar nebula is not very structured. It's a dense cloud in an empty space. So there's stellar nebula, there's a star cloud over here on the left. And from this star cloud, there can emerge average stars or massive stars. So average stars are smaller. They are going to burn slower. And I want to point out to you, I'm going to have a little bit of trouble doing that. This diagram is black, so it makes it very hard for me to write on it. But let's try this. These two stars are called main-sequence stars. So the main-sequence stars are the ones that are either average or massive. So if you see the term main-sequence, it's referring to either an average star, which is the size of our sun, or a massive star, which would be much bigger than our sun. And remember the point of a star. The purpose of a star is to fuse hydrogen to form helium. So these main sequence stars are doing that fusion. That fusion, nuclear fusion, is occurring in the main sequence stars, regardless of how big they are. So let's go back to our term for red giant and also a red supergiant. So both of those are similar based on our terms, and let me read you that definition. You don't have to go back there. A red giant, I'll tell you a funny story about red giant in just a second. A red giant is a star that has used up its hydrogen and expands. A red supergiant is a star more massive than the sun that has used up its hydrogen. So this concept of red giant means that the hydrogen is gone. So the fusion has occurred and the hydrogen is gone. It's used up. So when that happens, the star starts to expand. It starts growing into a giant. When I was a little girl, I saw this process or something on television. My mom had read me a story or something about this, but I became scared of red giants. And I thought there was a red giant living under the bed. So my father had to come in and chase out the red giant. For some reason, this just stuck in my 5-year-old mind, and I thought this thing was under my bed. So I always think of that when I do this diagram. But in reality, a red giant is a star that has used up its hydrogen. So it moves into the next life cycle. Now this is where things change pretty drastically. If you look at this life cycle, and if you follow that top trail, so the average star, after it uses up its hydrogen, it swells up into this red giant, and then it forms this thing, a planetary nebula. Now remember that nebula is cloud, so this is a planetary cloud. This is much cooler than a burning cloud. And what do you think possibly could form from a planetary cloud? Well, you probably guessed it. And remember our definition of a planetary nebula, planetary cloud, is, I'm reading from the ones that we wrote down without flipping back there. A planetary nebula is a red giant that has collapsed and becomes a hot core, hot center of carbon. So the hydrogen and the helium are no longer the issue here. The core is carbon. So if you look at this picture of, I'm sorry, it's telling me that it's going to do an update tonight, and I don't want it to do the update now, so I'm trying. Okay. If you look at this core of this planetary nebula, we know that that's the element carbon that is present in all living things. So that core right there is a carbon core. And planets can form from this cloud, this dense matter that's out there. Okay, eventually that planetary nebula will turn into a white dwarf, which is the last stage of this star's life. The star is dying, and it will eventually become a white dwarf, and that's the end of its life cycle. So let's follow the bottom main sequence. We know that average stars will end up as white dwarfs. This massive star, bigger than our sun, again, once the hydrogen is gone, we get the supergiant that forms. That will eventually collapse into a supernova. And let's remember the definition of a supernova. Super makes me think large, grand, massive, and it's simply the explosion of a red supergiant. So the supernova is the result of that explosion, that massive star that has run out of hydrogen explodes. And from that, two things can occur. One, we can end up with a neutron star. And this is just a star. This was not one of your terms, so I'll add it down here for you. I don't think it was one of your terms. No, it wasn't. So a neutron star is made of closely packed neutrons. And right now that may not mean a thing. But after we have covered some chemistry and I'll show you what a neutron is, you can remember that a neutron star has closely packed neutrons. Or that supernova can become a black hole. And you may have heard of black holes in Star Wars movies and so on. A black hole is an area that has gravity so strong that nothing can escape. No radiation, no matter, nothing can get out. So gravity is so strong that matter or radiation cannot escape. So radiation, light is a form of radiation. Light cannot get out. And in our Star Wars movies, we see that a spaceship that flies into a black hole cannot get out. And that's science fiction. But the concept is real, that nothing can get out of that black hole because the gravity is so strong. And those can form when a supernova is dying. So you may be thinking, first of all, I could not care less about any of this. You may be thinking there is no way I can remember all this. And the good news is that you don't need to. I just want you to get a couple of concepts here. First of all, that stars die. They're born in a stellar nebula and their life cycle eventually ends. So that's one thing. Stars don't live forever. I want you to understand that stars have hydrogen and helium when they're in their liveliest days. That another concept is that different stars die in different ways. They don't all follow the same path. And then the last thing I want you to get from this is just a knowledge of these terms. If this diagram were to show up on a test for you, I don't want that to be the first time you've seen those terms. So hopefully you will remember enough about stars to help you get those questions right on an exam. But I do not want you to memorize this. This is a pretty tough diagram to follow. The terms are tough. So I wanted to take a little bit of time to go through that with you. Okay, in the next video, we will move on to our next topic. And we are soon going to be finished with the space chapter. And we'll move on into chemistry very soon. So I'll see you next time. Have a wonderful day.